Okay folks, the purpose of this video is some basic revision of simple algebra. Okay, now when I say simple algebra, what I'm talking about here is manipulation of equations usually to solve for x. Okay, so the first thing we have to remember, whenever we see a question like this, it will say in it solve for. Okay, so when they say solve for, in this case x, what they're saying is they want a final answer with your x on one side equaling some number on the other side. So this is always our end goal, okay? Our letter that's in our equation on its own on one side of the equation, and whatever number we end up with as part of the steps we took to get that letter on its own on the other side, okay? And note that there's no coefficient in front of this letter, okay? So it's just 1x. It's not 2x or 5x or minus 12x, it's just 1x. So that is our goal. Now, the other thing that we need to remember when we're doing these questions is that in maths, when we want to manipulate an equation like this, there are only 4 steps that we can ever take. 4 things that we can do to manipulate an equation. We could add something to the entire equation, so to the whole equation. We could subtract something from the whole equation. We could multiply the whole equation, or we can divide the whole equation. And note, I keep saying the whole equation. Whenever you do something to part of an equation, you must do it to the entire equation. I can't just add stuff to this side here or take away stuff from this side. You have to do it to the whole thing, because our equation is like an old-fashioned scales. It has to stay balanced at all times. So when I want to do this equation here, or when I want to solve for this equation here, my first step is I want to have only my variables, that's my letters, in this case my 3x, on the left hand side of the equal sign. I've got a plus 2 here, I don't want it here. I only want letters on this side, because my end goal is x equals something. So far I have an x, I have a 3x, we'll deal with that later, but I have an x plus a number equals something. There's no plus anything here, it's just the letter on its own here. So I want the x on its own equals something. So I need to get rid of this plus 2. Now, I can only do one of these 4 things. How we know which to do is you do essentially the opposite of the operation in front of what you're trying to get rid of. So what does that mean in simple English? Well, the operation in front of the 2 is a plus. It's a plus 2. So I'm going to do the opposite of that. So the opposite of addition is subtraction. So I want to take away. Well, why do I want to take away? I want to take away because I want this to be reduced to 0. So what must I take away from 2 to make it 0? Well, the answer to that is minus 2. So what I'm going to do is I'm going to draw these 2 straight lines either side of it. And you don't need to do this, but a lot of people like to do it to help them keep track. These are what we call our stabilizers, to remind us that we're doing the same thing to both sides. So I want to put a minus 2 in front of the left-hand side. This represents that I'm subtracting 2 from the left. But remember what I said, whatever we do to one side, we must do to the other. So I must subtract minus 2 from the other side. So we're going to have on the left hand side here, well, the 3x is still going to be there. Okay, because we've done nothing to this. Okay, before anybody says, but 3 minus 2, folks, that's a minus 2. It's not minus 2x, it's minus 2. You cannot add or subtract numbers to letters. All we can do in terms of numbers plus letters is multiply and divide. So it's the minus 2 only refers to the plus 2 here. It doesn't refer to the x because there's no x here. So 2 minus 2 is 0. So now it's gone. And all I'm left is the 3x. You don't need to put plus 2 on that side, okay? That's not important. And then on this side, 11, and we have a minus 2. Well, what's 11 minus 2? It's 9. So we're already looking closer. We now have only letters on this side. The 3 in front of this x isn't the number 3, by the way. It's the multiplier 3. It means 3 times x, okay? And we only have numbers on this side. But I want 1x. I don't want 3x, I want 1x. By the way, what this is actually saying is I have a number. I don't know what it is. I'm going to call it x. 3 times that number is 9. I want to find out what my number is. Well, I want to change this from a 3x to a 1x. Now remember what I said. This 3 is 3 times. It's a multiplier. And I said up here, we do the opposite of the operation. So the operation here is multiply. The opposite of that is divide. So I'm going to divide the left-hand side by 3. But whatever I do to one side, I must do to the other side to keep it balanced. So 3 divided by 3 is just 1x. Okay? Now we don't need to, by the way, write 1x. I could have just wrote x, that's fine. And then 9 divided by 3 is 3. So my final answer, x equals 3. Alright? Next question. 2y minus 1 equals 9. Same thing again. What I want is x equals my number. That's my end goal. Or in this case, y. So I have a minus 1 here. I need to get rid of it. Well, we said we do the opposite of the operation. The operation here is take away, subtract. So the opposite of that is add. So I want to add something to this side so that this minus 1 becomes 0. Well, what do I add to minus 1 to change it into 0? I add plus 1, because minus 1 plus 1 is 0. Now, because I've added plus 1 to the left, I must add plus 1 to the right. So, simplifying this, 2y stays the same. Just as I said up here, it's plus 1. It's not plus 1y. You cannot add numbers to letters. We can add this number to this number. 1 plus 1 minus 1 is 0. And then 9 plus 1 is 10. Now yet again, I don't care about what twice my unknown number is. I care about my unknown number. Or in other words, I don't care about what 2y equals. I care about what y equals. So I have 2y, but I want 1i. It's 2 times y. 2 is a multiplier. The opposite of multiplication is division. So I divide. 2 divided by 2 is 1y. 10 divided by 2 is 5. So, next question. This one's slightly different to the first two. I have a letter on its own here, 2x, but I've also got a letter on the right-hand side. And I don't want a letter on the right-hand side. I only want numbers on the right-hand side and all my letters on the left-hand side. So we have to do the same thing again with our stabilizers. Only now we're going to try to get rid of a letter. So I have 1x here, or plus 1x. How do I know it's a plus? Because how I know is because there's no minus. If there was a minus, it would say minus x. Because it does says x, then that means it's a plus. So my operation here is plus. It's a plus x. I want it to be 0 x's. So what would I have to do? The opposite operation is take away. So I take away. But what do I have to take away from 1x to get 0 x's? Well, 1x. 1x minus 1x is 0. So I subtract x from the left-hand side, or sorry, from the right-hand side. But what I do to the right, I must also do to the left. Now let's deal with the right-hand side first. X minus x is 0. So all I'm left with now is the 5. So I have just 5. You could write plus 5 if you want, but we don't normally, so you don't need to start doing it now. Now on the left-hand side, I have minus x and I have a plus 2x. Well, what's 2x minus 1x? 2 minus 1. Just because there's an x in front of it doesn't mean the rules for maths have magically changed. 2 minus 1 is 0. Or sorry, is 1. So we have x equals 5. Or 1x equals 5. And it's now solved. So let's look at another example. Same thing again. We have letters on the left and we have letters on the right that we need to get rid of. Stick in my stabilizers. I have a plus 2x on this side. I want to get rid of it. So what would I take away so that it becomes 0? Y minus 2. You do the opposite, folks, as I keep saying. But what I do to one side, I must do to the other side. So, sticking with the right-hand side, 2y minus 2y is 0. All we're left now is the minus 4. No, it is a minus 4. That's fine. There's no problem with it being a minus. No one cares. If you have issues with this, then look, seriously, you just need to get over it. Minus numbers are just as valid as positive numbers, okay? And on the left-hand side, we have 3y minus 2y. Well, what's 3 minus 2? Y. So 1y. Now we've got a different question here, okay? So I haven't included the operation for this yet, but we have x squared. Now don't forget, I want x equals my number. That's what I want. I don't have x. You say, oh, there's only one x here. I don't. There's an x squared, okay? So I need to figure out what is the opposite of squaring something. Well, the opposite of squaring something is square root. This symbol here. So the square root of x squared and get the square root of 4. Whatever I do to one side, I must do the other. Well, the square root of x squared, the square root of any power of 2 is just the thing without the power. Okay, so I'm left with just x. And the square root of 4, what number when multiplied by itself gives me 4? The answer to that, folks, is 2. Okay? Now let's look at this question here. 2y squared equals 32. Okay, so there's a couple of things going on here. We've got a multiplier here and we have a power, okay? You want to make life easy for yourself. You do this by always getting rid of your multipliers first. So instead of 2y squared, I want to get rid of that 2 in front, okay? You don't do the squaring first. That cannot be done because of this multiplier in front. So if I have 2y squared and I want 1y squared, what do I have to do? Well, if the operation is multiplication, 2 times y squared, the opposite of multiply is divide. So we divide the left-hand side by 2. But if I divide the left-hand side by 2, I must divide the right-hand side by 2. So I had 2y squared minus, or divided by 2 is going to be y squared, or 1y squared. 32 divided by 2 is 16. Now we're going to get our square roots to get rid of these two, this power. Square root of y squared is going to be y, but whatever we do to the left, we must do to the right. The square root of 16 is 4. Next example. Similar to the... Oh, well, that's a typo on my part. That should be, obviously, an x, not a y. So, similar to the ones we were doing earlier, we have letters on the left on their own. We have letters and numbers on the right. We want to get rid of these letters on the right. So I have a plus 2x. And the reason I keep putting these down here, folks, is to remind you, with the exception of the square root example, I suppose I could put that down there too, these are the only things we can do. Add, subtract, multiply, and divide. You can get square roots and you can square stuff as well, but that's if they get slightly more tricky. 99% of the time, all you're doing in these sums is adding, taking away, multiplying, or dividing the entire equation. We can never do it in bits, as I keep always saying. You have to do it to the whole thing. So, I want to get rid of the 2x on the left, so I want it to be 0. So, how do I go from 2x to 0? I subtract 2x. 2x minus 2x is 0. But whatever I do to one side, I must do to the other. On the right-hand side, 2x minus 2x is 0. So we're just left with the 15. And on the left-hand side, 5x minus 2x is 3x. Well, I want x equals something on its own. I don't want something x equals something. I want just the x. So I need to get rid of this 3. It's not plus, it's not subtract. There's no plus or minus sign in the between these letter and this number. So that means this is a multiplier. This is 3 times x. So do the opposite operation. What is the opposite of multiply? Divide. Divide the left-hand side by 3. But whatever I do to one side, I must do to the other. Divide the right-hand side by 3. 3 divided by 3 is 1. X. 15 divided by 3 is 5. Now we've got a slight, similar to the other ones, but there's an extra step in it. We have letters and numbers on the left, and we have letters and numbers on the right. So we need to move stuff around twice. So what should we do? I would like to do with the left-hand side first. Okay? I want to get rid of this plus 3 on the left first. All right? So my operation is plus 3 or positive 3. Okay, what is the opposite to plus? It is minus. So I take away because 3 minus 3 is 0. Whatever I do to the left, I must do to the right. Now remember, it's minus 3, it's not minus 3x. So the 2x, nothing happens to it because we're not doing anything with x's here. So it's going to stay 2x equals. 3 minus 3 is 0. Okay? Now on the right hand side, we have, yet again, this x doesn't get changed because it was a minus 3, not minus 3x. But this 4 take away 3 is going to give me 1. So we're nearly there now, folks. We have letters only on the left, but we still have letters and numbers on the right. So what do? I do the same thing again with my stabilizers, but now I'm tidying up the right hand side. I want to get rid of this plus x on the right, so it's just a 0x, and all I'm left with is my numbers. Well, how do I go from 1x to 0? You take away 1x. Now whatever we do to one side, we must do to the other. So dealing with the right, x minus x is 0, so I'm just left with the 1. And then 2x minus x is, or minus 1x is x. So x equals 1. Another example here. We have letters and numbers on the left and on the right hand side. So first thing I'm going to do, tidy up the left hand side. Get rid of this plus 1. How do I get rid of that? You do the opposite. The opposite of plus 1, minus 1. Whatever we do to one side, we must do to the other. So we now have 2y stays 2y. 1 minus 1 is 0, so it's gone. So we're just left with 2y on the left. And then we have y plus 5 minus 1. Well, the y doesn't change because this is a 1, it's not 1y. 5 minus 1 is going to be 4. And now we want to get rid of the y on the right hand side. Stabilizers again, folks. Okay? So, how do I go from 1y to 0y? I take away. 1y minus 1y is 0y. Whatever I do to the right, I must do to the left. On the right hand side, y minus y is 0. So we're just left with the 4. And on the right, 2y minus 1y is y. And there you go. We probably won't have to use this, but just to keep it there, okay? Now, this one looks very similar to the previous questions. The first set of questions we were doing, we have an x plus a number on the left and no letters on the right. But we still have this number on the left that we want to get rid of. The only difference is I have a minus this time, okay? So I have minus 2. I don't want minus 2. I want this to be a 0. So how do I get rid of the minus 2? You do the opposite. What is the opposite of minus 2? It is plus 2, okay? Whatever I do to the left, I must do to the right. Plus 2 minus 2 is going to be 0. So all I'm left with on the left-hand side is x. All right? 4 plus 2 is 6. Next question. Same thing again. I have letters and numbers on the left-hand side I need to get rid of. It's a minus 2. I want to get rid of that. As we saw above, to get rid of it, we add 2 because minus 2 plus 2 is 0. If I'm at minus 2 on the number line, and I want to get from here to here, I go 1, 2. Okay? So that's what I'm doing. Plus 2 on the left, plus 2 on the right. 2 plus 2 minus 2 is 0, so I'm left with 2x. And then 4 plus 2 is 6. So yet again, we're nearly there, but I have 2x equals, I want 1x equals. So this 2, there's no plus or minus between the x and the 2, so that means it's a multiplier. So I want to don't want 2x, I want 1x. How do I change it from 2x to 1x? The opposite of multiplication, division. Divide by 2. If I divide the left hand side by 2, I must divide the right hand side by 2. 2x divided by 2x is 1x. 6 divided by 2 is 3. All right? Next question. So we now have letters and numbers on left and right. I wanted the same thing as before. I want to tidy things up one step at a time. I'm going to start off by tidying up the left-hand side. I have minus 3, and I want to go from minus 3 to 0. How would I do that? I would have to add plus 3, just like in the number line example above here, okay? So, plus 3 to the left. Whatever I do to the left, I must do to the right. All right? So, minus 3 plus 3 is going to be 0. Now remember that I don't add the 3 to the y because it's 3, it's not 3y. You can't add numbers to letters. You can't subtract numbers from letters, okay? So I'm only left with 3y on the left, okay? On the right-hand side, yet again, I can't add or subtract this 3 to the y. So it stays just as a y, it's not changed. I can add this. 5 plus 3 is 8. Now I have only letters on the left, but I have letters and numbers on the right. So I need to tidy it up again with my stabilizers. I have a y here and I want it to be 0. How do I go from 1 to 0 or 1y to 0y? You take away, subtract, doing the opposite. But whatever I do to one side, I must do to the other side. So on the right hand side, y minus y is 0. So all that's left here is the 8. 3y minus 1y is 2y. Okay, so I want y equals, I don't want 2y equals. It's 2 times y, that's what this means. The 2 in front of the y is a multiplier. There's no plus or minus between the number and the letter, so that means it's a multiplier. So I must do the opposite. The opposite of multiplication is division. Divide by what? Divide by the number in front. And if I divide the left-hand side by 2, I must divide the right-hand side by 2. 2 divided by 2 is y. 8 divided by 2 is 4. Now, another one. We have numbers and letters on the left, we have numbers and letters on the right. We want to tidy them up. I always like to start off by tidying up the left hand side. It doesn't matter which way you do it. I prefer to tidy up the left and then the right because in the English language you read from left to right. That's the only reason I'm doing it, okay? So, I want to get rid of this plus 3 on the left. All I can really do To manipulate an equation is add, subtract, multiply, divide, or get the square root or power of. Okay, so I want to get rid of this plus 3. I want it to be 0. How do you go from 3 to 0? You subtract 3. But whatever I do to the left, I must do to the right. Tidying up the left-hand side, the y stays on its own because this is minus 3. It's not minus 3y. There's nothing you cannot add or subtract numbers from letters. 3 minus 3 is 0. Minus 2 is the same. And then 12 minus 3 is 9. Plus 9, folks. Don't forget your powers here, okay? So, I have numbers and letters on the right. The left is good, but I need to tidy up the right. I currently have minus 2y here, but I want it to be 0y. So how do I change it from a minus 2 to 0? You do the opposite. What's the opposite of minus 2y? Plus 2y. Okay, but whatever I do to one side, I must do to the other. So, starting off with the right-hand side, minus 2 plus 2 is 0, so all I'm left with is the 9. And then on the left-hand side, 2y plus 1y is 3y. Now remember, folks, I want y on its own, not whatever y on its own. So I have to deal with this multiplier here, 3 times y. To get rid of the 3, you do the opposite. The opposite of multiplication is division. So I divide by what? I divide by the number in front. Divide by 3. Divide one side by 3, I must divide the other side by 3. 3 divided by 3 is 1 or 1y. 9 divided by 3 is 3. Same again. I have letters and numbers on both sides. Okay? Tidy up the left-hand side first. I have a minus 4 here. So how do I get rid of this minus 4? You do the opposite. Plus 4. Whatever I do to one side, I must do to the other. Tidying up this side, the 2x doesn't change because I'm not doing anything with x's here. It's only numbers. 4 minus 4 is 0. On the right-hand side, the minus 3x doesn't change because there's no x's here. It's only numbers. 4 plus 6 is plus 10. Now, I've got it almost there, but I need to tidy up the right-hand side because I have numbers and letters here. What is the opposite of minus 3x? Plus 3x. 3x minus 3x is 0. Whatever I do to one side, I must do the other. Minus 3 plus 3x is 0, so I'm just left with the 10. And then 3x plus 2x is 5x. Well, I don't want 5x, I want 1x, so I must do the opposite operation. 5x is 5 times x. The opposite of multiply is divide. 5 divided by 5 is 1x. 10 divided by 5 is 2. Next example. Same thing again. I have numbers and letters on both sides. I need to tidy it up. So I only have a y on one side and then my number on the other. First thing I want to do, get rid of the minus 3. How do I do that? You do the opposite. Plus 3. Whatever I do to one side, I must do to the other side. Okay? So we have 5y is equal to, the plus 3 minus 3 is gone, minus 2y, 4 plus 3 is 7. Now I'm almost there, but I have letters and numbers on this side. So stabilizers again, I need to get rid of my minus 2y. How do I do that? I do the opposite. What's the opposite of minus 2y? Plus 2y. Plus 2y minus 2y is 0, so I'm just left with the 7. And then you must do the same to the left-hand side. 2 plus 5 is 7y. But remember what I said at the start of this question. I want 1y equals. I don't want 7y equals, so I must do the opposite again to change it from 7y to 1y. 7 times y divided by 7, you're doing the opposite operation. 7 divided by 7 is 1y. 7 divided by 7 is 1. Y equals 1. So, there is my examples. I hope they help. I hope they're, for those of you who had difficulty with your algebra, this is reminding you of where you've maybe made mistakes in the past, helped clarify some questions for you. I've written down here 12 questions for you to do. Take the time to look at these questions, pause this video, do them in your copy, try them, and then if you want, you can email them to me at my email address, and I can correct them and see if they are correct for you or not, okay? I hope this video is useful. Try not to wreck folks' home, heads at home, and please, everybody, take care of yourself, take a break when you need to, and remember to wash your hands.